Hello, welcome to topic 2.1. This is the worksheet help, homework help video. So here's the problems that we're doing for the assignment. First one, write the conditional statement in if-then form. So, number 10, two right angles are supplementary angles. So we've got really like right angles and supplementary. So which one is the hypothesis and which one is the conclusion of the statement? Is it if angles are right angles, then they are supplementary? Or is it if angles are supplementary, then they are right angles? So the proper way to think of this is if you have two right angles, so you've got two right angles, then this is 90 and that's 90 by default, they have to add up to 180. So if two right angles then they are supplementary. S-U-P-P for supplementary. Alright, that's how you work that out. What about the opposite? What about the converse? Is it true that if angles are supplementary, then they're right angles? What about this? What about these two angles? 60 and 120. These are supplementary, but they're not right. So, two right angles are supplementary, that's true. Supplementary implies right, that's not true. So you gotta be careful about how you talk. And maybe that's the whole point of doing all this. So we kind of analyze a little bit about what we're talking about. Wouldn't that be nice if the presidential debates coming up, they did that. They analyzed what they were saying before they said it. So you gotta work through the rest of those. Write the negation. Negation is the opposite. You're one or the other. There's no middle ground. So if I say the sky is blue, is the negation the sky is pink? No. The negation to the sky is blue is the sky is not blue. I'm not going to write this down. You can write this down. The negation to the lake is cold. Is it the lake is hot? Is it either cold or hot? No, because there could be warm. So the negation to the lake is cold. The negation is the lake is not cold. You're either one or the other. You're either cold or you're not cold. Alright, for 17, I'm going to abbreviate. You have to write them out just a little bit more. So write the conditional statement, P implies Q. Alright, let two angles are supplementary, and let Q be the measures of the angle sum to 180. So I'm going to paraphrase just a little bit. If supplementary, then add to 180. Alright, I can do that, that's fine. If this was a quiz, I'd write it all out. I'd say if the angles are supplementary, then the measures add up to 180. But because it's homework, I can just kind of abbreviate a little bit. Alright, next we got to write the converse. Q implies P. So that would be if two angles add up to 180, then supplementary like that. So that's the converse. And then now we have to write the inverse. Not P implies not Q. So if not supplementary, then not adding up to 180. If the angles are not supplementary, it says supplementary. If the angles are not supplementary, then they do not add up to 180. Notice I put the knots in there for the inverse. The converse, contrapositive, not Q implies not P. So if not adding up to 180, then not supplementary. Alright, notice again the knots are in there, and that's how those go. Last thing we gotta do for this is then decide whether your statement is true or false. So let's go through. Is it true that if it's supplementary, then they add up to 180? That is true. Is it true that if you add up to 180, then you're supplementary? That is true. And look at that. The statement P implies Q and the converse Q implies P are both true. This scenario is an example of what's called a biconditional. It's when the statement and the converse are both true. And we can use the form if and only if. So we could say two angles are supplementary if and only if the measures of the angle sum to 180. So that is an option for this one because it's a biconditional. And now we don't even really need to think about the rest of these because it's all going to be true. These two will always be true together or false together, and then these two will always be true together or false together. So if these two are true, then these two automatically have to be true. Alright, you can do 18 on your own. Number 29 says rewrite as a biconditional, which means we need to rewrite it with the if and only if. Alright, so for 29, I'm not going to write it, I'm just going to say it, so you can copy down my words if you want. The midpoint of a segment is the point that divides the segment into two congruent segments. So midpoint, and then divides the segment into two congruent segments. So I would say something like this. Think of this as like your P and this is your Q. A point is a midpoint if and only if it divides the segment into two congruent segments. So if and only if. Use 30 and write if and only if in here somehow. 38. Describe and correct the error in writing its converse. So remember, converse is Q implies P. It's flipped around. So the conditional statement was rain implies umbrella. So we can write it like this. Rain implies umbrella. That's kind of how I think about that. And the converse, they said if it's not raining, then I will not bring an umbrella. That's the wrong symbol for that. It's different in different classes. Okay, remember, what happened here is this just got knotted. I just added a knot. That's not the converse. That is the inverse. Alright, so there's a quick fix right there. On to the second part of the lesson. The type of reasoning, inductive, deductive, and counterexamples. Describe the pattern, then write or draw the next two numbers. Alright, so we're just this is obviously the alphabet backwards. This one goes up by 2, up by 4, up by 6, up by 8, up by 10, up by 12. So you can figure that out. This one is a little bit trickier. I'm not going to tell you what that is. I'm curious if anybody can figure out what the answer to that one is. What is the pattern there? Alright. Number over here. It says find a counterexample. Counterexample means the hypothesis. So you have hypothesis, then conclusion. The hypothesis is good. The conclusion is wrong. That's what we're looking for. So is it always true that the product of two positive numbers is always greater than either number? Can you think of a scenario where that's not true? So you got to find two positive numbers. So let's do an example. How about 2 and 4? 2 times 4 is 8. So in this scenario, we've got two positive numbers, and the result, the product, is greater than both numbers, 2 and 4. Is that always true? Is that always going to be the case if you multiply two numbers that are positive? It'll be bigger. What about 2 times a half? 2 times a half, those are both positive, and 1 is not greater than a half. So this is a counterexample. It's a counter. It shows that this is false. It shows it's false. I have to meet the criteria of the hypothesis being two positive numbers, and I have to disagree with the conclusion, greater. Okay. Let's do number 16. A line S divides M into two line segments, so the line S is a segment bisector. Alright, so here's segment MN, and it's saying that there's a line S, and it's shooting through here. Is it true that S has to be a bisector? It could be true. This could be like 7 over here, and this could be like 7 over here. That's not necessarily always true. You could have S like this, shooting through where maybe this is 2, and this is 8 over here. Okay, so doesn't have to be, just because it goes through the segment doesn't mean that it has to bisect the segment. So this is a counter example. It meets the conclusion of S dividing into two segments, but it meets the hypothesis, but it goes against the conclusion. Counter example. Alright. Moving on, decide whether it's inductive or deductive. Inductive is based on a pattern. Deductive is based on like a fact or an assumed proposition here. So each time your mom goes to the store, she buys milk. That sounds like a pattern. It's a pattern of going to the store, buying milk, going to the store, buying milk. So the next time she goes to the store, she will buy milk. That's inductive because there's an established pattern, and we're basing our reason. Is it possible that she could go to the store and not buy milk? Yeah, inductive is a little less for sure than deductive. Next, 32. Rational numbers can be written as fractions. That is that's a fact. Irrational number cannot be written as fractions. That's a fact. That's how we define those. So 1/2 is a rational number. I'm basing this conclusion off of this definition of a rational number. That's deductive because I'm basing my conclusion off of something that's been accepted. In this case, the definition has been accepted. Whereas this one is not based off of a definition. So we do 33. And then 45, decide whether each conclusion is valid. Here's the criteria you're working with. Can you conclude that you went camping in Wyoming if these things are true? Okay, so you went camping in Wyoming. Alright, Yellowstone. Is there anything about camping? You and your friend went camping at Yellowstone. So camping implies Yellowstone. Okay, is there anything about Yellowstone? Yellowstone is in Wyoming. Yellowstone is in Wyoming. So you went camping in Yellowstone. Yellowstone's in Wyoming. So it would make sense that camping implies Wyoming. So I would say you went camping in Wyoming. That checks out. We can go ahead and make that conclusion based off of this one and this one. Okay, so now you got to see if you can make other connections with B, C, and D.